Now, hi everyone. Let's do a quick round of introduction, I would say. Hi, I'm Philip. Who is next?
Hi, I'm Rai. I'm with the Logstash team.
I'll go next. Hi everyone, I'm James. And there's
Hi,
Alex.
I'm Alex. I'm also part of the community.
Yeah, so as you can see, we are almost too many people. That's why we will split this up into two groups, basically. Or James goes first about finding or detecting the bad stuff about Log4Shell. That's why hopefully all of you are here. That will take us until 45 or so. Probably we'll throw in a 3-minute break for everybody to get a drink and do a bio break. And then right, Alex and me will continue with like what is the security stuff happening in the Elastic product. What should you do? What shouldn't you do? What is dangerous and what isn't dangerous anymore? If you have any questions, as always, don't be shy. Just drop it in the chat and we'll try to pick it up as we go along. And I think with that, James, you have the full plan. So we'll remove ourselves and we'll leave you with James now. So see you a bit later. Good luck, James.
Thank you, Philip. Hello, everyone. Good morning, evening, afternoon, wherever you are. I guess we all know why we're here on this session today, and it's all about the amazing happenings with Log4j and the vulnerability dubbed as Log4Shell. So in my part, I'm going to go over pretty much everything there is to know about Log4Shell that we know, because more is still being discovered, right? So we're going to go through what it is. Actually, we're going to go, I'll bring up the agenda because it's all described there. I put on the logo because it's a really good logo. It's not well designed because it's such a terrible vulnerability, just in case anyone didn't realize that. So what am I going to be covering in my part? So first of all, what is Log4Shell, the vulnerability found in Log4j? Who discovered it, how it works, how do you tell if you are vulnerable? And then we're going to go through an actual exploitation. So we're going to run an exploit together. And then I'm going to simulate being a blue teamer and going through like the detection with Elasticsearch. However, we're also going to be using Elastic Observability today because it says a really good story in being able to detect this particular vulnerability. After that, we're going to go deeper. We're going to examine the exploit step by step. So why was our app vulnerable in the first place? So we're going to take a look at the code. We're going to take a look at a bit of everything. And then what happened? So what happened when that vulnerable code was run? So looking like almost like reverse engineering this a bit. So we're going to go really, really deep. We're also going to take a look at not only what our code does, but since this vulnerability uses sort of a malicious LDAP server, we're going to look into there as well, what the LDAP server actually does and what it responds with. And then we're going to go over a few additional resources and links because thankfully the community at large has been really, really helpful in providing resources to be able to detect and respond to Log4Shell. With that being said, let's dive right in. So what is it? Well, I'll start off with saying it's pretty terrible. For anyone who's been dealing with this the past couple, 10 days now, I hope you're taking a break for your sanity. I hope you're keeping your mental well-being intact because it's a tough one, right? It's very, very intense, and I'm sure most of you have been at this for a very, very long period. So keep that in mind. Yes, it's important to remediate, patch, detect, and respond, but also take care of yourselves. So what is it, right? So essentially, the Log4Shell vulnerability was found in a Log4j library, which is an extremely common logging library for Java, which is one of the most popular coding languages there is today. It was a 0-day exploit, meaning there was no patch available when it was discovered, and it led to remote code execution, meaning anyone with access to the internet can exploit a vulnerable server and run code on those servers. I put in a screenshot of what's become, I think, a very famous string that's been being used. This is just an example. There are way more, but this just give you an example of how a vulnerable string would have looked like. So who discovered it? So the first CVE that was made public on the 10th December was actually discovered by the Alibaba team, Alibaba Cloud team. This basically led to the first set of events. So everyone trying to find out what it did, all those IOCs coming out, a lot of information came out about it. It was pretty bad. And then we got the first patch from Log4j. So I think it was the 2.15 patch, which unfortunately wasn't enough. We found another CVE by a few other people. So, obviously people started to really dig deep into Log4j, and 2 more vulnerabilities were found. The last one being on the 16th December. So there's been quite a bit happening. A lot of people have been working really hard on this to try and get to the a final stable patch, which is Log4j 2.17 as of today. But we're going to get more into that in a bit. But I think it's important to recognize the who and the what, because so many people are involved, and it's thanks to these people that we had a really good starting point to start looking at patching these vulnerabilities. So how does it work? I was going to draw this out, but there are so many good drawings about it and diagrams that I'm just going to reuse 2 of my favorite ones. The first one here on the left-hand side is via the Swiss CERT team, and it explains it really well. The other one is by a website, I think it's pronounced Security Zines or Security Zines, I'm not sure, but it also explains it pretty well. So how does it work, right? So if we hone in on this one over here, well, it starts off with a vulnerable server. This vulnerable server is running some bit of Java code, usually a web application, which is using Log4j for logging. So an attacker would basically send an HTTP payload with a malicious string anywhere. And when I say anywhere, it could be any part of the payload that could potentially get logged. So this could be the request, it could be headers, it could be authentication strings, it could be anywhere. If you assume someone is going to log something, attackers have been putting payloads pretty much anywhere, and we'll see some examples of that as well. In this case, we're seeing that the attacker put in the vulnerable string, I should say the malicious string, in the user agent string header. So attacker sends the payload. Once it hits the vulnerable server, a couple of things happen. So if the vulnerable server is logging that request, so if it's logging the user agent string that was used, this string is passed to Log4j, and from there, Log4j, this is where the malicious activity and the vulnerability starts to get exploited. Once Log4j sees this string, in this case, it's being told that it's going to use an LDAP server, so the lightweight directory access protocol. It's going to query an LDAP server to see what its results it's supposed to get for logging, get them back. And what ends up happening is the malicious LDAP server returns either a Java class file that needs to be downloaded or serialized Java data, which we're going to look at an example, but this is sort of what the LDAP server responds with. So either serialized data or a URL of where to download a malicious Java class file from. Once that happens, it makes its way back to the initial Java application, and the Java application runs it, because that's what it's instructed to do from Log4j. So there's a lot of moving parts. This diagram also has some mitigation steps, but we'll cover mitigation a little bit just after this. But it's very elegant, I think. And it's very trivial as well. So unfortunately, that's why it was so treated with such urgency, because if you're hosting a malicious LDAP server, there's a very good chance that there's many Java servers that can reach it over the internet. Unfortunately, not everyone does outbound ACLs from their Java servers. So it's very, very crucial to get patched. And also it means you can pretty much run any bit of arbitrary code on the backend server. So that's how it works. Again, we're going to get into more detail. I'm going to run through all these steps live together. So we're going to go with each and every one of these steps and see what it looks like in a real attack. Now, this was actually a Black Hat presentation from 2016, where they were talking about potentially this vulnerability getting exploited with the JNDI references, which is the Java naming directory interface, I believe. And in fact, this is what's being exploited, this bit of poisoning, so to speak. So you can see here later when we query our LDAP server, we're going to see something return similar to this. But when Log4j uses JNDI, I've been saying it JNDI, you can say it however you want, let's say JNDI for short. When it queries using JNDI or JNDI, that LDAP server, this is the response it gets. So you can see, hey, here's the server that's hosting the class. This is the class that you need to download. And it goes ahead and downloads it. But just pointing out that this was a talk from 2016. So unfortunately, we learned the hard way about what happens with these sort of attacks. Are you vulnerable, or are we vulnerable? In short, probably. So hopefully you've been patching. Again, I was going to draw this out, but this is a really, really, really good diagram. I've left the link in the bottom of the slides, and we'll make these available after. But essentially, the key points, if you're running Java less than these versions here, so 6 version 2.11, 7 version 2.01, or 8 version 1.91, you are, it's possible to have that class injection. And then you also have to see your Log4j library version. So anything as of this point less than 2.17, you're probably vulnerable. And then you also have to see, there's a bunch of other stuff to take into consideration, but this plays it out really, really nicely. But in short, if you're running Log4j less than version 2.17 and Java version less than 8.191, you are very most likely vulnerable. It might not mean that remote code can run because you might have other mitigations in place, but that Java version with that Log4j version is vulnerable. So let's begin, right? I'm going to go through all of this step by step. We're going to run an exploit first, and then we're going to dive into it. I put out our setup here just because it's a bit easier to understand what might be going on. So I'm hosting a vulnerable application server, which is running Java, Spring more specifically. I'm also hosting a malicious LDAP/HTTP server because that's what happens. Because the attacker, remember, needs to instruct Java to download the malicious class from an HTTP server or send the serialized data. My host is running Elastic Agent with several integrations. So we're running endpoint security, we're running network packet capture, we're running OS Query Manager, we're running Docker, metric collection, we're running a custom log integration because my application does log. I'm vulnerable because I'm running Log4j. And this application is also instrumented with our Java APM agent. For those of you who aren't aware, Elastic has an APM offering, which essentially allows you to instrument your applications. Java is very popular for this, of course. And in fact, Java is probably the easiest to set up because you don't actually have to change any code. You can just attach it to your running jar file. And the server and Elastic Agent and everything is reporting into Elastic Cloud, Elasticsearch service. So I'm going to run an exploit, and let's see what happens. So let's bring up my terminal. All right, so this is that server here. For the sake of simplicity, I'm going to run the exploit via curl. So let's just go ahead and do that. Exploit Log4Shell. So I'm going to run the exploit, but before we dive into the exploit, first we're going to see what I can see as someone defending before diving into the actual fact. So I'm going to run it. That's it. Let's run. So as an attacker, what did I do? I queried, or I should say I made a request to my web server, which is running on localhost port 8080, and I sent this particular header. We'll look into the contents of the header later, but as you can see, I'm using the X API version header. I don't know, as an attacker, I don't know if the vulnerable application is logging that header, but this is what I tried. Like we've seen people try out many different headers, again, trying out requests, trying out a bunch of different stuff. this is what was returned, this hello world here. So essentially, this is just what my Java application is sending back to the user once they make a request. If you remember, this request is just to root. So this is sort of the main page there. All right, so now let's dive into Kibana. And we're going to look at Elastic Security to see what we can spot. All right, so we are in Elastic Security here. This is pretty much everything that you're going to see is out of the box content, right? There is no custom work or custom rules or anything. Everything is set up as you would get it from today, right? So just want to point that out. The only, I would say, non-standard from this demo is the APM side, but we're assuming in this case that the organization, like I have my organization set up, is instrumenting their apps. It could be a different team, but it's all reporting into the same cluster. So I have, again, all the default rules set up. What I'll do is I'll just quickly show you the actual policy as well from an Elastic Agent perspective. But again, it's all literally as you'd get it out of the box. All the rules, the SIM rules, everything. So this is our host here. I'm just going to show you the policy. So again, we saw this in the slides, but I just want to dive a bit deeper into the endpoint security policy here. So we have our malware preventions on for all operating systems. Ransomware preventions are on. Memory threat, malicious behaviors, and we're collecting all these events. Everything else is pretty standard. So if we look at our system metrics, again, just standard stuff, nothing special. And this custom log here is because we are collecting our application logs as well. So obviously, it's very common if you're running a web server, you're probably collecting those logs as well. Because this is a custom Java app, I'm using the custom log file collection. And that's it. That's all I need to do. Cool. Let's go back to alerts, see if we see anything. All right. So we have two new alerts here after I ran that exploit. One is malware prevention, and another one is suspicious Java child process. Let me zoom in a bit, just to make sure everyone can see. I'm not monitoring the comments or the chat, by the way, because I'm using a single screen today. So I apologize if anyone's commenting or asking questions. We can get to those later. So let's look at the first one. I have a malware prevention alert. Let's change to our event rendered view. I find it easier to read. And it's on our host, which is saying, hey, root on this host was prevented from modifying a malicious file, Mosey, in temp Mosey via wget from the server via parent process of shell. Interesting. Okay, so let's use our event analyzer, get a bit of a deeper view here. And we can see pretty much a process review of what happened. What's interesting is it's coming from Java. Now remember, I'm as a defender here, not knowing what happened yet, not knowing that Log4Shell was exploited. So I'm just investigating this as this alert came in. So we can see I have a running Java process which spawned a shell. We can see the arguments here, which is what we saw before. And then wget downloading the file and the two associated network events. But this was prevented, thankfully. So we're running that malware prevention. So this file was actually detected as malware by us. And we can see it here. We're also collecting threat intelligence in this cluster. And we had two threat intelligence matches as well, as we can see here. More in particular, I'm collecting this data from abuse.ch. And we can see we had a hit there. So whatever file was downloaded here, thankfully it was prevented from running. But how did it end up on my system? We saw the Java parent process, and immediately after, there's also there's an alert for suspicious Java child process, which is very similar to the malware prevention alert. So just taking a look at that, again, pretty much identical, right? So what's happened here? If I take a look at the Java process, we can see the process executable. We can see the parent process ID. We can see the process arguments. So this looks like our Java application running here. Very, very interesting. Okay, so I know that whatever happened, it was initially invoked via Java. Now, it is the week of the 20th December. I have been hearing about Log4Shell all over the news. There's also, if we take a look at our security overview page here, I can see that Elastic has told me that there's been a Log4j exploit. So why don't I go ahead and confirm if on that host we have any Log4j libraries running. So later we can do further analysis if that's the case. I'm actually going to use OS Query for this. So if I head over to our host view under observability, I'm going to pick that host and I'm going to check. I'm going to run OS Query through here, just playing the observability story. Where is my host? It's this one here. And I can see running processes through here, but I'm gonna go even further. I'm gonna run OS Query because I have a really nice query that looks for specific Java libraries. And we're gonna share this query was actually shared by the FleetDM, the people who maintain FleetDM, which is another way of running OS Query at scale. It's really, really good. So I'm gonna run this query, which essentially shows me if on that host I do indeed have those libraries. Takes a few seconds. It's a pretty sophisticated query. So what it does in the background, it's actually checking processes that are running with associated files on disk, and it's also running a Yara check to look for specific strings. If we look at the results, here we are, put them in full screen. I actually have a few matches here. So I have a few jar files which are running log4j, and specifically some of them have the JNDI lookup class. So you can see this is the same app we saw that initiated the malware download. I'm also running a few other things like Logstash. I'm not fully patched yet. Cover your eyes. But this confirms that this app is actually running log4j with that specific class. So why don't we look further? I'm in observability at the moment. I'm going to go and head into our APM view. And I'm going to look at our services. So I know that our application is being instrumented by APM. And I can see it over here. And let's do the last 15 minutes to see if we had any transactions and if we had any data from there. So I can see in the last 15 minutes, we had a transaction being hit, which is this main controller index transaction. I'm just going to go ahead and click it. And let's see what we have. And now this is pretty interesting because remember, so far we have no idea how that Java process ended up running that wget command. Right? So let's take a look. So this is the initial entry point into the application. So we can see here all the metadata. So we can see, zoom in a bit, things like the HTTP request headers. And here is a very suspicious looking header. Again, as a defender, I don't know what was exploited yet, but I can see, oh, in our XAPI version header, we have this very suspicious looking string. We can see the user agent, we can see the host, we can see, again, the same process title, the same process ID. Very, very interesting. Okay. What happened right after? So after this was invoked, we see a GET request to this IP address over here. What is this? So if we look at the metadata of this, we can actually see what the GET request was. And this GET request was made to this server looking at looking to download this specific class. If you remember from our explanation slide, it's all starting to come together already. So we've downloaded a Java class. Why is that? But as you can see, just having this view of the data, no WAF, would have caught this as an example. Very few other security tools would have been able to look at this from at this level of detail. So it's just really, really handy to have this bit of data. And thankfully, this organization had it. So we can see that class was downloaded. We can also see now our application was, if we look at the service map, we can see our application communicated to this IP address over port 8888. This hasn't happened before. So if you're in a situation where you're instrumenting your applications and all of a sudden there is a rogue backend service to an IP address with a random port, that is something you want to look into. If we go back to our transactions, there's one more thing I want to look at, because remember, so far what I know about Log4j is it's supposed to log something, right? So I have the option to look at my trace logs. What does that mean? So this invoked a stack trace, right? And this invoked these transactions to happen. What is the associated log with these trace? So if I click on this, we're going to get a filtered view of what was logged, because it might lead us to understand if what was logged and how it was logged and why it was logged as well. Because this was invoked because something was logged because we're using Log4j. So we're just going to wait that to load. As you can see, we filter specifically for that trace ID. And because we're collecting our application logs, we do what we call log and trace correlation. So in the background, automatically, if you turn that option on, we will correlate your application logs with your trace logs. And here's a very interesting log entry. So it's telling me my Log4Shell application as an info log received a request for API version. And if you remember, in our API header, we had that string. So it looks like we are logging that X API version header, right? So we now have a very good understanding how this was triggered, right? We're logging our X API header request, which we ended up with this string. So next thing is, what actually is this string? So if we grab this string, which we can see it's running a basic command, which is base64 encoded. So I'm going to assume this is a base64 string. Remember, again, as a defender, I still don't know exactly what was being run. And I'm going to copy that. I'm going to use a very popular service, base64 decode. And lo and behold, we end up with the command that was run. So just to recap before we dive even deeper into how all of this worked, we started off looking at our alerts, right? So within our alerts, we saw that we had a malware prevention alert and a suspicious Java child process. We looked into our malware alert, and it turns out that this command was actually spawned from Java. Thankfully, it was prevented, so the download was successful, but it was immediately quarantined, so it's not on our server, so it couldn't run, which is great. And after we found out that that was initiated from Java, we took a look to see, based on what we're hearing in the news and based on all the tweets I'm seeing about Log4Shell, we looked on our server to see if we have any potential vulnerable libraries, because we queried specifically for Log4j classes and the Jindy lookup class as well. And we did see it running on the server. So we hopped over to our APM traces, and we were able to see that request in APM. We saw the request coming in that was showing the header that was sent. We also saw that a follow-up GET request was made to a web server, and we saw the correlated log with the trace, which we grabbed the base64 content and pasted it here. So that's how we ended up with that file. Excellent. So how did this all work? So now we take off our blue hat and we start looking at our blue teaming hat, and we look a bit at the binary. So we look at our red team, we put on our red teaming hat. So I'm going to go over to my server here, and let's dive into this for a second. So the first thing that happened is when we exploited, if we remember back to our diagram, our app queries an LDAP server. We can make that same query, right? Actually, before I do that, let's look at our actual app. So if we look at the source code of our app, this is the file that made that is using the logging. So the whole reason it happened is because I am invoking Log4J over here. So I have a logger named logger. It's called hello world. And you can see that I am logging the API version. All right. And remember, we returned hello world as well. So we can see that over here. So this is why it all happened in the first place. If I wasn't using the vulnerable version of Log4j and I didn't log this request, I wouldn't have had any of those results. So that's the first step, right? Seeing why that happened. Now, then what happened? So once it got logged, the vulnerable Log4j version looks at that string. It knows it has to use JNDI and look up the LDAP server. So this is what would have been returned via the LDAP server. So I'm just going to run literally a curl using that same command. And this is what Java receives back. I should say Log4j receives back. So you can say Java codebase, which is the malicious web server, which we saw in our APM trace. We can see the object class and the Java factory. Basically, this ends up being the class that we're going to run. It might have a different name now because this malicious LDAP server generates a unique name for the class every time. So we can go a bit deeper. We can actually use a tool to look at the contents of this. So some of you might be familiar with Marcus Hutchins. Marcus, or known as Malware Tech Blog, he actually created a tool that would I should say, make the LDAP request and immediately download the HTTP class, because if you try and do that as a human, you probably don't have enough time to do it and they stop serving the class. So this little Python script does both at the same time. So let's do that. All right. Yes. All right, so what does the script do? So basically, again, we queried for that same object. We got the payload, and unfortunately, there was nothing uncompiled, but we did find the compiled class. We have another tool available to us, which allows us to look at compiled Java code. This is a tool called JD. So why don't we go ahead and look at the contents of this class? So this is what ends up being run by our vulnerable Java app. And you can see, even if you're not too familiar with Java, it's pretty straightforward. This ended up as the command we passed via base64. It's basically doing a check here to see what type of operating system it may be, so either Unix or Windows. And then it basically says, run this array of strings. That's basically what happens, which ended up in us in the application trying to download the file. So this is how it all comes together. It's really, really cool. There's a lot of, when I say cool, I should say it's cool because it's elegant and it's been there for so long. And it took us this amount of time to actually find someone to report and see it get carried out the way it had. But being able to get this level of detail is quite nice. Thankfully, Java is so common that a lot of people were able to dig into this pretty quickly. So again, I'm going to make all these tools available, but that is essentially how it worked, which is, yeah, it was interesting to me at least. One more thing I'd show is this application, this vulnerable app, I did get from a GitHub repository, which again I've linked to. The only thing I changed is setting the logging to a file. So if you remember when we did that trace correlation, we were logging to a file. All I did there was add our ECS logging library, which looks like so. So you can see, if you remember, we had our logger named hello world. I basically instructed it to use this Log4Shell appender, and you can see the ECS layout. So this is pretty easy to do if you're running Java applications, literally a one-liner. You just have to add the dependency, and then you can set up this logger. So that's the only change I made to this app, to log to that file. Excellent. All right, so I think I have one more slide to show, and then I'll hand it back over to Philip and gang. So we spoke about a lot. Thankfully, there's quite a few good resources. So us ourselves as Elastic, we've published a few things. We've published a series of blog posts, and I highlighted the two with quite a bit of detail in there. I myself have also published an open Elastic cluster with honeypot data. I'm not sure what that looks like for a second. So if you need to see sort of what is exploit attempts are happening in the wild, I've made that data public. This Reddit is really, really good. It contains a bunch of other links in there. And these are some of my other favorite ones as well. So those mind maps and Gray Noise have published really good detail, and a ton of IOCs, and also Cloudflare have given really, really good detail. So there's been so many people giving out information about Log4Shell. These are just a few of my favorites. So hats off to anyone who's provided any form of resource for the industry to use. I'll just show you what that looks like here. I have the cluster with the honeypot data in there. So you can go to this now, log4shell.threatsearch.io. And you can see there's a lot of repeat offenders, as I like to call them, but a lot of the requests are very common. So this basic command, base64, is what we used. There's a few others. People are trying different things, but this is definitely the most prevalent. And what I mean by people are trying various different headers, I'll show you that in a second. So if we expand one of these documents here, we can see various requests. So we can see it in the request itself. I think, yeah, I don't think there were any other headers for this one, but that's why I included quite a few columns here, because so many different, I'm seeing it come up in so many different headers. It's a very wide and extensive search in this case, and thankfully Elastic can handle it without issue. So that's it from me. I appreciate this was a lot to take in. So remember, this will be on the community YouTube channel after. So if you need to go and watch it again, you definitely can, or read our blog post, because we do get into detail there. And I do plan on publishing a blog post with the observability resources as well. You can learn more about Elastic Security. Just pop in our community Slack is extremely active, or we have our Discuss forums. Again, you can go and use it for free for 14 days on Elastic Cloud, or run it yourself. From a security perspective, and even APM, all the features I showed are 100% free. So if you haven't found something that gives you some sort of visibility or protection, particularly for Log4Shell, go ahead and use our products as much as you like. That's it from me. And good timing as well. So I will hand it back over to the team.
Well, we are just joining you. I think, James, there was one question in chat from Nave, where we can find the log file that has the vulnerable parameter.
Where we can find the log file that has the vulnerable parameters. So it doesn't. So just to clarify, it doesn't necessarily mean that it has to end up in a file, right? So your application might be logging to console to standard out. In my case, I was logging to a file. So this is totally going to depend on your application. So just to make that clear.
Cool. Any other questions? We still have 5 minutes left. Otherwise, we might also do a 3-minute break for everybody to grab another coffee, and then kick off at 45 as promised. But I think this is your last chance to ask some questions to James. Otherwise, what we'll do after short break, or maybe we'll entertain you in the meantime as well, is I think Alex and me will go first on Elasticsearch and the APM agent, and then Rai, you were good with closing off with Logstash and what that entails. So I hope we can have that for everybody. And yes, just like Watson InfoSec says, thanks a lot, James, for doing a great presentation as always. It has been busy few days, right?
Sorry, I was a mood. It has been extremely busy few days. I have blurred out of reality with Log4Shell. Even though it's not directly my job within Elastic, as a security person, it has entrenched me. And it's been just fascinating to see. For me, what was fascinating is that how quickly everyone responded to it and how quickly everyone started to help each other. That is amazing. That is what we should do all the time. But yeah, it's been a heck of a week. And a huge shout out to everyone at Elastic who was working weekends to patch and do everything that we did. We did 2 emergency releases in less than a week. So yeah, it's been wonderful to see that.
Right. And I think everybody was surprisingly positive on Twitter as well, even for the creators of Log4j, because, well, they were working on in their spare time and fixing everything in their spare time and answering tons of questions. So everybody was, I think, very understanding, even though it was a very unfortunate situation and created lots of work for everybody around. But that's part of open source.
Yeah, absolutely.
Sounded an understatement. You mean, sorry, I cannot pronounce your username. You mean the understatement is like the amount of work it created for everybody, right? Yeah. Well, we agree.
And it's unfortunately it's going to keep creating work, right? So it's not over just because we have the patches. Like, doesn't mean everyone patched immediately. And what's tricky with this is we might not know our full vulnerable landscape. Right? Java's everywhere. That's the not the problem, but that's why this is such a big deal, right? Because everyone's seen the Java prompt. We run on 3 billion devices. Amazing, thanks. So yeah, there's a lot of Java out there.
Yeah, I think one of the main things here is that it's an asynchronous vulnerability, right? Because it's probably that you write your logs into a file and you just collect them sometime later with the Java processing component, and then you have absolutely no idea what triggered this, on which server this arrived. It's just there at some point in time, and this is what makes it so mean also to detect, right? It's not just I have my observability enabled on this application. If it gets processed somewhere in the back, it's going to be really tough to just find it in your completely microserviced infrastructure.
Absolutely. And even the breadth of ways to do it as well. So we went through the simplest way using the JNDI:LDAP, but the number of variations we've seen, it makes it just really, really hard to just do a traditional standard, search or grep through a log file or that sort of thing. So that's even more tricky. Like, there's so many different kinds of ways to exploit this as well.
Yeah. And one thing that I've seen that some people assumed, like, well, for example, Elasticsearch is behind a firewall, so nobody can reach that. So it's not exploitable, but that's not really how this thing works, which is a bit unfortunate here. Because if your application just hands over whatever string it got to the backend, it still has it, even though you haven't exposed anything, and you think like, oh, this is not reachable, this is fine, this is well hidden. If it passes on the unsanitized string, it's still there, and you still have the problem to fix. So yeah. So we've almost filled the time. I'll give it 1 more minute, then we are at 45 to kick off the next block, just to stick to our schedule as promised. Thanks again, James. You're off now for holidays, right?
I am off from tomorrow, indeed. Well,
good. Enjoy
we'll see if any other Log4Shell stuff comes out. Probably. I'll do my best.
Thanks,
Yeah,
James.
there's more than one logging library for Java, so let's see what happens.
Yep.
So let me add this one. I think we're at 45, so I think we'll kick it off. Alex, I'll leave you on. Ryan, James, I'll put you in the background. I'll see you in a moment again. So Alex, please stop me whenever you feel like it. But we wanted to dive a bit into Elasticsearch and then to maybe a minor degree or lesser degree into APM agent. What does Log4Shell mean for Elasticsearch, since it has been a lot of fun and entertainment for us as well? So as James has already shown you the initial logo, as the second issue was kind of like getting worse and like its vulnerability score was increasing, the creators of the logo actually made the logo worse, because they said, like, as the security issue gets worse, they will keep making the logo worse. So this seems to be what we are having by now, that this is the official Log4Shell logo, and this is how bad this situation got. But in the context of Elasticsearch, there was the initial security issue that was what triggered everything. There is the advisory on Discuss that describes what this means for all the Elastic products, which is probably a good side note right now, that whenever there's a security issue in the Elastic products, it will go to discuss.elastic.co, and then there is a security section. You can subscribe to that by email or by RSS. So every time we publish an advisory there, you will get the update. Initially, people were a bit confused where to find our advisories. It's on Discuss. Like any other question or topic that is worth discussing, we will publish them on Discuss, and that's where you can find them. And this link, we'll have it at the end again, is the current state. It has been continuously updated, what this really means for all the Elastic products, like what is affected, what is not affected, and how badly. And the main issue was the initial security issue with the straight 10 out of 10 badness, because, well, remote code execution is as bad as it gets. There were the 2 follow-ups CVEs, but they only apply under certain situations when you have a non-default pattern layout. So that's kind of like the structure of how your logs will be written out. And then you need to do the right kind of context lookup to actually trigger it. And these 2 conditions are actually not met in Elasticsearch, for example. So while these are security issues that you probably still don't want to have in your products for Elasticsearch, they did not apply, because we are not using the pattern layout in such a way where these are affected or effective. And we're not using the context lookup in a way that would be needed. So those 2 don't apply for Elasticsearch. Only the initial one is the issue. And we put together this handy table going through the 3 major versions where Log4j 2 is being used in Elasticsearch. So if you are on the very latest, what James mentioned on Sunday, 7.16.2 came out, on any JDK, you don't have any issues because this is using Log4j 2.17, so this is not affected by this anymore. If you were using 7.16.1, which was the first patched version that we brought out, that one didn't upgrade Log4j, but we removed the JNDI lookup class, and we set that Log4j format message no lookup to true. And this is still effective on any Java version against both remote code execution and information leak. Remote code execution, as we've seen before, is if you load some information into Elasticsearch and it will then trigger whatever you want. The information leak is more about an DNS exfiltration, where you might be able, for example, to exfiltrate some environment variable or some system property. I hope most of you don't have any environment variables, for example, with your AWS secrets added to your Elasticsearch service. Then the information leak might be a concern as well. But like I said, it does not apply in 7.16.1, for example. If you're on an earlier version, that is any version of 7 before, including 7.16.0, and you were using at least JDK 9, which is also the default one. So if you download the Elasticsearch binary with the JDK included, we were always shipping a JDK greater than 9. So then you don't have the remote code execution problem and you don't have the information leak, because what is protecting you there is the Java Security Manager, and we'll show you the right class in a moment, or the right property or setting file, where the Java Security Manager is kind of like kicking that vulnerability or lowering the vulnerability. and the JVM defaults that are applied to 9 in combination with the Java Security Manager made this not exploitable on any version of 7. If you were using a lower version of the JDK, if you manually installed the JDK and you set the ES Java home manually, and you were using Java 8, for example, then you have the risk of an information leak. And to fix that, you could or you should set that format message no lookups to true, as described here, and we'll show you the full command later on. You are still being protected by the Java Security Manager, so you don't have the risk of a remote code execution. On earlier JDK versions, this is what this little 1 here means. If you want to be extra sure, you can set the same setting to any of the nodes, and then you would have like an extra layer of protection. But basically what this means is you set this JVM property, you restart the node, you can check on the API if the property has been set, and then you know that you're also protected against any security issue there. So this is the situation for 7.x. Since I've been referencing the Java Security Manager a couple of times, so deep within Elasticsearch, so somewhere in source main resources org Elasticsearch bootstrap, there is a file called security policy. And that one is the so-called Java Security Manager, where you can basically sandbox on the JVM what different pieces of code, for example, are allowed in terms of what files can you access or what network calls can you do. And the network calls actually come in very handy here. So one thing that we globally set is that everything can resolve, so basically do the DNS lookup. This is what comes in with the DNS exfiltration, because every library that we load in Elasticsearch can do a DNS lookup. But it cannot connect, for example, to another server. So our Log4j library is not allowed to make any outbound network calls, which also kind of makes sense, because what would be the point of Log4j doing any network calls from an Elasticsearch node? Nothing really, except for downloading some code for a remote code execution. So thanks to the sandbox, this was not allowed. We only allow in a couple of places the network connection to go out. That is, I think, Alex, only Netty, right? That allows that?
Yes, that is the plan.
Yeah. So we are very restrictive what can actually fetch something from the network or do an outgoing connection. And thanks to that, thanks to the Java Security Manager, it's not possible to download any code and do the remote code execution in Elasticsearch. If you have 6 or 7 where we apply these very strict Java Security Manager policies. So that's kind of like what saved the bacon or saved the day here in terms of Elasticsearch. In 5, we didn't have that strict security manager rule yet, and that's why this one is more vulnerable than the previous versions. So looking at 6.x, 6.8.22 got the latest Log4j version as well, so that one is definitely protected. 21 was also protected by the same way that 7.16 one was protected. We removed the JNDI lookup class and set that parameter. For 6.0 to 6.8, thanks to the Java Security Manager and the JVM defaults, the same applies. If you were using the small or a version with a lower JDK and you were using 6.4 or up, then you can also set that parameter. Earlier versions in 6, so 6.0 to 3, are using such an old Log4j version that it doesn't know that parameter yet, so you need to remove that GNDI lookup class manually. Still, the Java Security Manager still protects you against any remote code execution because the logging library cannot do any network calls, which also kind of makes sense. And on version 5, unfortunately, like we said, the Security Manager was not as strict, so you have the risk of a remote code execution, plus information leak as well. And since 5.6.11, you can set the JVM option on earlier versions, you need to remove the JNDI lookup class. And if you're still using a version below 5.0, so some version of 2 or 1 of Elasticsearch, which you shouldn't, but also you shouldn't use any 5.x version anymore. You should really upgrade to a current version. But before 5, we were using Log4j 1.x. So you were not affected by this security issue, but you probably have other worries then anyway. If you want to figure out what the exact Log4j version that you're using is, I've pulled up a couple of links to the source code here. So in the 7.15 branch, in build tools internal version properties, for the past 3 years, any version of Elasticsearch has used any Log4j or the Log4j version 2.11.1. All the versions were using earlier 2.11 versions. So this is 6.4, which was the kind of the first one to go to 2.11. But if we go down to 6.3, you can see we were using Log4j 2.9. This is too old to apply that JVM option. So from there on, you need to remove the Jindy class to actually secure Elasticsearch. So if you want to figure out what version of Log4j you have, you can look it up in the source code on the branch for your specific version to see what you have and then mitigate that. To actually set the JVM option, so this is the simplest example where I'm just adding the ES Java opts parameter and say format message no lookups true, and then start Elasticsearch. It's all one command. Then this will apply it. You also have a JVM options file or a JVM options D folder where you could add a file with that setting. On ECK, the operator, you can add it as a parameter as well. So there are ways to always set that option on any version that uses at least Log4j 2.10 to protect your Elasticsearch against any Log4Shell. And in combination with the security manager, that is effective and is all you need, even though this might not be true for some other versions. Finally, removing the Jindy lookup class, if you take the zip file and remove from whatever Log4j version you have, and you remove the Jindy lookup class with this command, then you're also secured because then you cannot do the vulnerable Jindy lookup. And I think that's pretty much it in terms of breadth what I wanted to cover. Alex, do you have anything else to add?
No, I think we're good. Like one of the side effects of the security manager or the logging library not being able to write over the network is also that you can't use network file appenders for logging. It's just something that doesn't work out of the box, which you don't really notice usually, but if you try to configure it, it usually fails as well. It's one of the few things where users tend to notice that things don't work as expected.
Which for performance reasons, maybe you don't want to do, or maybe if something drops on the network, but yeah, that's a different discussion, yeah.
You should not try to do that anyways.
Yeah. And I think one other interesting point is because of the strict Java security manager settings that we've had, it wasn't so easy to actually upgrade Log4j. That's why for the last 3 years, Log4j was using 2.11 and hasn't upgraded to 2.12 and 13 because there were always some conflicts with the Java security manager and it wasn't really a high priority, I guess, to upgrade it. It wouldn't have made any difference because it was a 0 day, so whatever latest version we would have used would have had the security issue anyway. But now we've made a bigger change to actually go to 2.17 straight away to be done with this issue.
Yes, and as you can see here in your code sample, you see that this only applies for the Log4j core jar. There are tons of Java applications which have the API jar included, for example, which is not a problem. For example, I think many Spring Boot applications use Logback by default, but still have different Log4j jars in their distribution as well, which are not vulnerable because they don't contain this JNDI lookup class. I think that's something, if you really want to check for dependencies, make sure you check for Log4j core and not for other Log4j2 dependencies.
And while removing the Jindy lookup class protects you, some security scanners are not smart enough and just check like, do you have a Log4j core version in a vulnerable version included somewhere? And then they will say like, your application is vulnerable. So in part because of that, we turned up to 217, even though removing this lookup class was effective. It's an uphill battle against bad scanners. So at some point you want to get rid of those, I think, and move to the latest version, even though you are protected by removing that class. Which, yeah, we've seen a lot of support cases because of that. Alex, you wanted to say something about the APM agent, right?
Yes, sure. Because like the moment we released the new Elasticsearch and Logstash version, we also released the new APM agent version. There's one major difference, and that is the backwards compatibility, because the agent still supports Java 7. There was no way of upgrading to the latest Log4j version, so the first fix here was also... Sorry, I just repeat the last sentence. I'm not sure if I got cut off. So the APM agent supports Java 7 because it just needs to be more backwards compatible with older versions. So there was no way we could upgrade to the latest Log4j2 version. So the first release, 128.1, did the same as the Elasticsearch release. It just removed this Java class. But in the meantime, for the next Java agent version, there was basically a release for an older Log4j version. I think it's 2.12.1 or 2.12.2. Let me quickly check. It's 2.12.2, and that one supports Java 7 as well. And this one is now used in the agent. That said, by default, you could not use this vulnerability in the APM agent because you would have to change the log level of the agent itself, what kind of messages it emits to the log level of trace, which is info by default. And you would need to use the plain text format so that the agent itself emits its own messages in plain text format. This is the default. But many users also nowadays use JSON. So that's an important thing to keep in mind for the APM agent. There was no exploitation by default. And yeah, that's pretty much all I have to say about the APM agent. Just make sure you upgrade to the latest version as well.
Easy. To come back to Carla's question, I haven't tried it, but I would assume if I just removed the logging jar, I think it won't boot up anymore, though I haven't tried that recently.
Yes, there's basically a lacking dependency.
Yeah.
That means classes that are used by the Java code of Elasticsearch cannot be found, so you get a class not found exception, error, and probably the JVM will just exit on startup.
Yeah. So what you cannot do either, and that one I have tried, is if you drop the 217 jars into an earlier Elasticsearch 7 build, it will not start up because of Java Security Manager exception. So if you want to get the 217 Log4j jar, do an upgrade of Elasticsearch with that version, but don't just drop it in because that will not work. I think in 216, the Security Manager was not as strict, or in version 5 and 6, the Security Manager was not as strict, so you could drop in those jars, and I've tried to boot up the server and it worked. But the Security Manager could still run into issues at any point in time, so that's definitely not recommended. Remove the Jindy lookup class. That is what is tested and recommended where it's necessary, or set the JVM option where that is an option, and those are the safest paths. And other than that, just upgrade, or just upgrade once you can to the latest version of 6 or 7 to get a proper version of everything and be done with it. Which is also like a good chance now. Any other questions? What you should or shouldn't do, or what is important or what is not important? If you were using Elastic Cloud, we were using an insecure JVM option before, or version before 7.2. There, if you restart your cloud instance, we will apply the JVM option automatically for you. So you don't have to do anything. Once you make any upgrade, resize the cluster or restart it, so on any restart, we will automatically apply the JVM option to protect your Elasticsearch nodes. And I think we are also putting, or we already have put fixes in place if you have like ancient versions, if you're like an old customer and still have 5.x running on Elastic Cloud. There are still a couple, I think. We have mitigations for those in place as well. So on Elastic Cloud, we'll do the work for you. But most of the versions there should not be vulnerable or can easily be fixed by the JVM option. if there are no other questions right now, I think we can hand over to Rai. And let me remove my slides. Add Rai. Hi, Rai. Add his slides, and I'll remove myself. If you have any questions about Elasticsearch or anything, don't be shy, just type and we'll pick up on that. But over to Logstash now.
Hi, I'm Rai Biesemeyer, one of the principal engineers on the Logstash project. As we discussed, there were the flurry of 3 related CVEs on Apache Log4j, all involving untrusted user input being handed to the logger. Let's just talk about it from the Logstash perspective. Since Logstash is a tool specifically for processing logs, we have to worry about anything that is logged by any upstream application, not just applications that are themselves vulnerable. Some Logstash plugins very helpfully log the contents of an event or field when an action produces an error, which makes all versions of Logstash that included Log4j2 affected by the CVEs. A malicious actor with knowledge or reasonable assumptions about the pipeline flow could inject events that would exploit the vulnerability. The extent of the vulnerability really depended on the version of the Java VM Logstash was running on. Older unpatched JVMs had full RCE, while more modern JVMs were limited to information leakage, such as the contents of environment variables. When the first CVE was publicly announced, the Apache Log4j team provided 2 paths forward for in-place mitigation. My teammates Rob Bavey and Joao Duarte quickly identified which versions of Logstash were affected, and that removing the JNDI lookup class followed by a process restart was the only effective in-place mitigation. The system property flag was not a good mitigation for Logstash due to the way that our log appenders are constructed. As upstream patches from Log4j became available, we released a series of 2 patch releases on each actively maintained branch of Logstash and in each relevant bundled plugin. The first of these upgraded Apache Log4j to 2.15. The other 2 vectors were subsequently announced, and we determined that either of our mitigations for the first vector was sufficient to also mitigate the new vectors. Any 7, 6, or 5 series Logstash could be fully mitigated in place by removing that JNDI lookup class, but both Logstash 7.16.1 and 6.8.21 do fully mitigate all 3 CVEs out of the box without any additional patching. However, to avoid false positives from automated scanners detecting a version of Apache Log4j with known CVEs, we followed up with Logstash 7.16.2 and 6.8.22 once Log4j released their 2.17 that kind of stabilize out and resolved everything. So both of those releases do include Log4j Core 2.17. For long-term mitigation, we really do strongly recommend using one of the latest patch versions of Logstash on a modern JVM. As of today, if you're running Logstash 7x, that means 7.16.2. If you're running 6x, that means 6.8.22. Logstash 5 is affected by these vectors, but reached its end of life back in 2019. Logstash releases older than 5. We're using an older Log4j that doesn't have these specific vulnerabilities, but is older and unpatched. If you can't immediately upgrade, or you're running a version of Logstash that has passed its end of life, the JNDI lookup class removal outlined in our security announcement remains an effective in-place mitigation for these CVEs. So if you need to do that temporarily while you pull back to a development environment and test an upgrade, that's fine. But we do recommend mitigating this as soon as possible and not just waiting around on it. I would like to really thank my team for their effort. It certainly was a team effort on all fronts. Rob and Joao led the charge through the first CVE's mitigation. My teammates Kaisi, Andrea, Andres, and Carol pitched in with rapid patches and reviews for potentially affected plugins, and Karen worked tirelessly to ensure documentation and the release notes were in shape. I really thank you to my team. And that's about all I have today.
So, last chance for any questions. Otherwise, we'll wrap it up for today. And I mean, it has been more than an hour anyway, which is kind of long for our virtual meetup. So thanks everybody for staying around with us. Good luck everybody with patching your vulnerabilities in all your products, including ours, but everything else as well. Hopefully it will be a quiet Christmas for all of us.
Indeed.
More or less. Cool. No more questions. Then I hope everything is clear. Thanks, Rai. I think Alex had to take care of his kid now. So we just made it. And everybody enjoy the rest of your day. Thanks. Bye.
Thank you.